Well, we got a full house tonight. I'm really happy y'all came out because that traffic was awful. I almost didn't make it myself. So, welcome to the Austin Hardware Startup Meetup. It's been running for almost 2 years now. I'm Bartley Gillen, your host, your organizer, your champion of hardware entrepreneurs. We have a special guest. Clarence is actually from Mountain View, and Intel tapped him as a community leader, speaker, guru, if you will. He's been at a few of their hackathons. And we have Intel to thank for our pizza, our beer, and at least 3 giveaways. I know there's some Intel employees here from the Austin office, so hopefully they'll pass on the cheers. But so there's going to be at least one demo after, maybe another. Clarence will go for like 30 to 45 minutes. We have a hard stop at 8:30. So somebody punch me in the face if we haven't gotten out here by now, or by then rather. There may be beer left, there may not be, but if it's there, eat it, drink it, whatever. Have fun. We're all here to learn. Without further ado, I'll give it off to Clarence, and he'll school us on IoT.
Hi, I'm Clarence. Welcome to the Hardware Meetup. I just flew in this morning. My second time is in Austin, and I love it a lot. Last time I was here was for New Year's countdown this year, so I like it. So I'm actually not from Intel. I just graduated from college in June, and I went to a lot of hackathons in the summer after graduation from college. Actually, I went to like 12 hackathons in a row. Because, I just graduated and there was food at work. I work in a startup, except on weekends. So I went to hackathons on weekends so I could get food. Okay, so just like to poll the audience a little bit. So who has worked on an IoT project before? Cool, so about half the room. And has anyone worked on Intel development boards, either the first gen Galileo or the second gen Edison? Okay, so not a whole lot. Actually, the boards were just released in September, I think, and there was a roadshow hackathon here in Austin in September. There was one in Mountain View in October. So I think the Austin one was the first hackathon that they had that they released the Edison and Galileo boards on. So that was cool. I participated in the Mountain View Hackathon in October, and my team won a prize. So Intel liked us, I think, and got us to be community speakers. This is my first one, and I think I'm going to a few other in various parts of the country in the coming months. So that'll be interesting. So if I do make any errors or mistakes, forgive me. I'm perhaps less, I'm perhaps less experienced than all of you, or many of you, in hardware hacking. So I'm here to learn from you guys and to present some of my thoughts of working with the Edison board. So yeah, bear with me. Intel said we could talk about anything we wanted, anything. They didn't give us any, direction on whether we should promote the Edison board or criticize it. I think that's great because the Edison board is great, but it also has a lot to improve on.
Hello.
Yeah. So I'm not an expert in anything at all. I'm not an expert in edge computing. I'm not an expert in IoT. I'm just an amateur hacker who happened to work on the Edison board and work on a cool project that Intel liked. So I'm here talking about IoT and edge computing. So who am I? As I said, I'm Clarence. I originally am from Singapore. I went to school in Stanford. I graduated with a BS and MS in computer science. My majors were in artificial intelligence, so I work on a lot of machine learning stuff at work. My day job, I work as a software engineer in a startup in Mountain View. It's actually a pretty cool startup. It's called Shape Security. And they're giving me time off to come here, so I gotta put in a word for them. Yeah, we do code obfuscation. So if you think about it, a lot of websites face problems because people are scraping their content and people are doing credential stuffing. If a hacker steals like 5 million passwords, he won't try them on different sites one by one. He'll write a script to do that. And in order to run a script to stuff in the stolen credentials, he has to be able to identify the correct fields to stuff them into before submitting the form. So what our product does is it morphs JavaScript code into various different formats that are pretty much impossible or at least difficult to identify. And this is just one of the examples whereby you have a simple static JavaScript thing, or a simple static HTML thing, and you're creating the form field with JavaScript code. Just one example. I'm not supposed to reveal all of them because we're a security company and we're pretty, paranoid. So we're hiring profusely. We just raised the Series C, and we're hiring a lot. So if you're interested, come talk to me after the meetup.
Any thoughts about moving to Austin?
Maybe in the future if we expand. I actually have a lot of friends who graduated college and moved straight here to Austin to work at Google and Rackspace. And I think Austin's a great town it's a great city for startups, especially because of the environment here and the kind of people it's attracting. So I think it'll be a hot choice. Intel is really hot on social media now, a little bit awkwardly so. I love Intel a lot. They have this hashtag Intel Maker. It's actually quite interesting if you go on Twitter and search for Intel Maker hashtag. You can see people from all around the world working on different projects that have to do with Intel. You can see people complaining about Intel hardware, and the Intel people are actually pretty responsible about responding to these complaints and feedback. So if you have any feedback or suggestions for Intel, feel free to tweet with this hashtag IntelMaker, and they'll get to you pretty soon, freakishly soon. So today, what I'm going to talk about is what it takes to prototype an IoT project. I am not necessarily the most qualified person to talk about this because the only hardware hack I've done, besides the Intel one, is a previous one I've done with Electric Imp. So in my life, I've done a total of 2 hardware hacks, IoT hacks. So I'm here to learn from all of you guys. If you have any corrections to make, or if any suggestions, or if you feel like I'm saying something wrong, feel free to stop me at any time and give me comments or just make a remark. Intel did not influence any of my talking points today. I'm not paid by Intel. They are sponsoring my trip, but yeah, they're not paying me otherwise. I think what they have now is pretty darn cool, but the Edison, as I said earlier, also has a lot of points for improvement, and I hope that you guys will be inspired to use the Edison today, and then find points that can be improved and give suggestions to Intel. Okay, so this is the Edison. I'm sure all of you have at least seen a picture of it, if not in real life. The Edison is tiny. It's about the size of a postage stamp. It's 10% larger than an SD card and about 25% thicker. It's a brain. It's kind of similar to the Raspberry Pi compute model. So compute module. So the Raspberry Pi compute breaks out pins in a common RAM module output, but the Edison uses a 70-pin connector, of which 40 pins are available to us users. So yeah, the reason why it's so small is because Intel is really trying to target the wearable market. It has inbuilt Wi-Fi and Bluetooth Low Energy, so it's pretty easy to just use it out of the box to create IoT projects, and that's why a lot of hackathon projects end up being more interesting when they use the Edison because they spend less time trying to configure modules and can spend more time on the actual application. This is the actual makeup of the board, the hardware on the board. I won't spend a lot of time talking about it. I spent even less time talking about this. You can find this online. Yeah, I think it's pretty interesting that the Edison is so small yet has built-in Wi-Fi and Bluetooth. Also, it has a full Atom processor and has a Quark microcontroller in it, which runs full x86 code, not 586 or anything the previous Galileo was running. So I'll just do a brief comparison between the Edison and other boards out there. The Edison with the Arduino breakout board is pretty much a powerful Arduino motherboard that runs Linux. In comparison with the Raspberry Pi and BeagleBone, it's smaller. It has inbuilt Wi-Fi and Bluetooth Low Energy, as I've said about 5 times now. It has no built-in support for video and audio, which is interesting because a lot of IoT projects actually do require AV support, and the Edison out of the box does not actually have drivers for audio and video. So I'll talk about it I'll talk about it later. But in my project, we actually rely heavily on the use of audio, and because of this, we have to take a long detour around it to get around this problem. The software stack, it runs Yocto Linux 1.6. It has pretty limited drivers. It has a very strong embedded focus, so you can make it more scalable in terms of what drivers you want on the product, and it's kind of hardware independent. But it's a little less maker friendly because of that, because if you want to add a driver to it, you have to recompile the kernel and do all of that stuff, which I didn't know any about. Yeah.
Quick little question. So with the driver set that it has, does it support SPI, I2C, digital UART, things like that hardware people would need to communicate? Say, for example, there's a computer that I can hook up a SPI LCD band. So
Yeah.
what kind of, does it have those drivers, SPI, I2C, and all
Yes,
that?
SPI I2C, it does have UART, it does have, but it's just things like AV component. For example, yeah, I'll talk about it later. The standard stuff that most hardware hackers use that can be found on Arduino or Raspberry Pi is available, but it's just stuff that is perhaps a little more on the edge that is not available, and it's not that easy to add support for it. So that's why. Okay, so breakout boards, I'll just touch on quickly. The Edison has several breakout boards available. Intel has 2 that it made available, and these are official ones. The Arduino breakout board and a small breakout board that's really meant for production or close to production prototyping wearables. SparkFun also kind of saved Intel's ass by coming up with a whole bunch of blocks. I think those are really interesting. I actually ordered a bunch of them before today, but they didn't come in time, so they're not here. So the community is really embracing Intel's boards. Seed Studio Grow starter kits are available as well, and I think Intel sent one set here for a raffle. They provide shields and sensors for people like me who aren't really sure of what components go with what hardware boards and stuff like that. So it's pretty much plug and play. Talk about a couple of convenient library frameworks that Intel Edison has available. Lit, MRAA, there's high and low level wrappers that allow you to use the sensors, to use the connectors to support low level communication protocols. It's interesting that Intel chose to support Python and Node.js, which are typically higher level programming languages that software engineers like myself are more used to working with. I work very little with C and C++, so they are really targeting software engineers as well as hardware engineers. I think this opens the IoT or hardware hacking door up to a whole slew of people, because in the past people would be intimidated by having to write programs in C or with very low-level libraries. And it's cool that Intel has this library available in a range of languages, and I think they plan to support more in the future. UPM is just a high-level repository of libraries that demonstrate the use of a lot of common components. So quickly, I'll just go over some pros of the Intel Edison. There's a cons page as well. I think I've touched upon a lot of these already. The Intel Edison board is a strong compute engine. It has an Atom system chip that runs up to 1.6 gigahertz, 3D graphics acceleration, and a USB 3.0 stack. So power management is pretty great, and I think they focus a lot on that because they really wanted it to be a wearable chip. So it doesn't heat up at all. It's 615 MIPS, about 2 times the compute performance of the Raspberry Pi Module B. And Bluetooth supports Bluetooth Low Energy, Wi-Fi supports BGN, Wi-Fi Direct, and even has a Wi-Fi Direct access point capability. So it comes pre-installed with Node.js and Python, and it really allows you to deal with a lot of hardware without having to go into C and C++. Also allows for SSH connection over USB. So the cons, it's not super maker friendly. I worked with the Arduino previously, and I found it really easy to implement some hardware projects. But with the Intel Edison board, I think it still requires some investment of time and effort into learning how to get some drivers working. Even though it's a Yocto Linux stack, it's scalable, but it's not that easy to install some software, for example. They do not use YUM or apt-get. They use OPKG, which is like the Yocto equivalent of apt-get. So the most straightforward way to install drivers, packages, and other dependencies is during Yocto build time. So you actually have to go through a pretty lengthy build process to get this done, and it ends up being a very complicated process for many. A standard suite of drivers and packages should be made available, but I think as of this time, as of this release, firmware and software version, it's not yet available. Though I think Intel is pretty responsive to these feedback. So I think they are going to release one with that's more maker friendly soon. Okay, so are people familiar with the Yocto system framework? Okay, so it's pretty much a system that's open source. It's funded by Intel actually, which I recently found out while making these slides, so it's interesting. It offers developers more resources for creating applications in their favorite programming language. It includes GCC, Python, Node.js, OpenCV, etc. It has a steeper learning curve than many Linux-based maker boards, but it's appropriate for industrial applications because you can have fine control over each element in the root file system. So if let's say you're trying to make an IoT hardware hack for small-scale production, I think this would be much more suitable for it than something which includes a lot of bloated drivers and packages. You can build just what you need into the kernel. You can optimize boot time and ensure that your system can fit within tight memory constraints. So this is important, and I think Edison supporting this shows that it's targeting a certain market and it wants people to get products out of the door. So this is our project. It's called Chain Check. I'm done with all the Edison stuff now. I'm going to talk about something that I care more about. Chain Check is. I'm sorry. I didn't mean to say like I didn't care about Edison, but like all those things that I presented on, I think you can pretty much find a whole bunch of people reviewing the board online, and the specs you can find online. I think this is what interests me more.
Before we move to that, two quick questions. Question one is, documentation to me is very, very important. I don't have time to waste with anything.
Yeah.
So now that you've went through it, and this is one of my pet peeves about anything Linux, is that it's just like, figure it out yourself, it's so much fun. No, it's not. So now that you had to do this, how was their documentation? Did Intel take the time to have their tech editors sit and write their own documentation? Or they're like, just go out on the internet, go to forums, or tell me about that. And the second question is, I'm waiting and seeing what the price happens with this module because it is expensive compared to a lot of other things. Do you have any inside information? I'm surprised that Intel's making it so expensive. Are they going to drop this price down anytime soon? So those two kind of things, documentation and price.
Okay, got it. The first one about documentation, I have to be honest, during the hackathon, it was a short amount of time and we had to find we had to find out about a lot of things from scratch. I find that Intel actually has good documentation out there, but when you're actually Googling the relevant keywords, they don't necessarily come up in the top few results, or necessarily even in the first page. So I think that's interesting because if they're spending a lot of time writing the good documentation and complete documentation, maybe you should spend a little bit of time also doing some SEO to push those results up. Or paying Google. That being said, I have actually reflected this to the Intel technical staff, and I think they are working on getting this solved. They do recognize the importance of good documentation, and I think everyone does, because it's really frustrating to work on a board when you have to crawl through forums and look for something that might or might not work. So documentation is pretty complete, but finding it is not that easy. Intel does have a developer page which you can search for documentation you want, and everything is actually on there. The search functionality is not great as well, so you just have to find it. Yeah. About the price point, I don't actually know. Big reason why I showed up for the Intel Hackathon was because they're giving out boards. I'm not from Intel, and I don't think even their technical staff know about price points because it's such a big organization. So all I can say is I think if you think about the kind of components and functionality that it has Bluetooth and Wi-Fi, so you don't have to purchase any additional shields or components. So it's actually pretty comparable to other boards that, in addition to Bluetooth and Wi-Fi. So I think it's still competitive, though you really have to decide if you want to invest in this or you want to invest in something else, which you can swap out the sensors and modules for more easily. Though this is much smaller than anything out there, so yeah. Okay, ChainCheck is a project that my team and I worked on during the Intel IoT Hackathon. I think it's pretty interesting. It's basically the Intel Edison board connected with an audio input sensor, and then it also has some other indication sensors like lights and LEDs. So what it does is that the microphone is connected to your bicycle, and then it records the sound that your chains and derailleurs make. And over time, it'll be able to get a pretty representative sound signature of how your bike is supposed to sound like. If your bike's sound signature changes over time, it'll be able to give you an indication of what perhaps is wrong with this. And this is of course just an idea. We weren't able to validate all of this during the hackathon period, and we're actually still working on that because this has to do with the field of predictive analytics. And in order to verify the accuracy of such a mode of error analysis, we have to go through a long period of user testing. So we're still in that phase now, but I think the idea itself is pretty cool. Predictive analytics is not a new thing, as I learned recently. Companies do this on the industrial scale. I found out from an Intel technical guy that there was actually a company in China, I believe, that went to an Intel industrial show that actually did something similar. Their company worked on predictive analytics for factory equipment. So they will attach vibration and sonar sensors to machines in large factories, and then they'll use the same concept basically to tell if the machine was going to break down or if it required more lubrication, etc. Also, I think there are a lot of startups now that deal with predictive analytics in terms of health. I saw one in the news reports recently that it basically was a wearable that would be detecting your heart rate, and if anything anomalous were to come up, they would send you a signal, and then you can go check it out. Seems like magic initially, but I think it actually makes a lot of sense. Why we decided to work on this was because I'm interested in the machine learning part of things. I think the hardware part of things for me for this project is just a bonus. It helped me to learn a lot about hardware hacking, and just get an intro to what working with hardware is like. But what really interested me with this project was the machine learning aspect of it. How to do proper anomaly detection with sound signatures, I think was a problem that a lot of people would be excited about. So, as I mentioned, machine learning is a method that we use to do anomaly detection. And then anomaly detection is what we use to achieve predictive analytics. So I'll this question.
I'm sorry, I'm curious, how precise was this? Because as a cyclist, I can tell if something's wrong with my bike, but I might not necessarily know immediately, oh, it's the cassette or the rear derailleur or whatever.
Right.
Is it that precise? You had it down to the parts?
Right. Okay, so the question was if it was that precise, and if this method of predictive analytics was able to pinpoint the exact problem. Yeah. So I think the idea is that we will consider this project successful and this method of anomaly detection successful if it's able to detect something that humans cannot. I think a lot of problems that come up with bikes are, pretty visible, or you can hear if something's wrong. And it's successful if you can't tell that something's wrong, but something goes wrong eventually, and the machine's able to tell, but you're not. So we have been able to detect some things like, for example, if the chain requires lubrication. We haven't spent many hours test driving this thing, but if the chains require lubrication, there is actually a pretty significant change in the sound signature that's generated by this thing. And a lot of problems with back chains and JOS actually arise from lack of lubrication, or if you require some other parts being twisted here and there. I'm not a bike expert, but we do have a friend who's a good friend of another team member who's given us some advice on this, so I'll take his word for it. So let me just delve into some small aspects of the machine learning part of this project, because I think it's important, and a lot of wearables actually have the chance to gather data about yourself and about the things that you care about and use. And I think with this data gathered, you can do a lot of interesting things with it. You can do predictive analytics, or you can do any kind of classification. You can get intel about your life. You can get intel about how you can improve the way you live your life. I think this is something that a lot of hardware hackers perhaps are not that exposed to. And it's interesting to see what people are able to do when they are, when they do things with machine learning and hardware. So we use this software called OpenSmile, which is an open source program that's used for speech recognition originally, but you can extract features in the audio file, in the raw audio file, and from this you can do anomaly detection. So once you're able to extract certain features from an audio sound clip, you're actually able to classify sound clips by you can plot a point in Z space to signify where this point is. And then you can cluster sets of points in order to see if this is a normal point or not. There are a few different kinds of anomaly detection, mainly unsupervised, supervised, and semi-supervised. So I'm not sure how familiar people are with machine learning, but let me just quickly touch upon each of these points. Unsupervised anomaly detection techniques deal with non-labeled data. So if you think about it, when you're in the field and you're collecting data, let's say bicycle chain sounds. This is not a very common data set to find online. You can go to Kaggle, or you can go to the statistics department, the census. They get data on population and the number of people that are in a town or city, but you can't find data like this. And so it's even harder to find data on what constitutes a normal bike sound and what constitutes an abnormal bike sound. So unsupervised learning is really the way to go for a lot of projects and interesting things that people haven't spent a lot of time on. Supervised anomaly detection is when you have a data set and you either use Mechanical Turk or yourself and label data sets. If you can tell what's a good sound and what's a bad sound, you go through the data set and label it, then you train a model in order to in order to correctly predict future sounds that come in. That's not your training set. Semi-supervised is kind of like the middle ground between these two. You spend less time training. You actually have a data set that you classify into a training set and a test set, and then you just build a model such that you maximize your prediction accuracy on your test set by training on your training set. So there are a few different ways of doing this. I think I'll talk about 4 of them. One is a density-based technique, which is K nearest neighbor, KNN clustering. So basically, you define a constraint K, which will be used as a metric for classification. And then after you extract features from the audio file, you plot them onto a vector space, and then you can find groups of points that minimize the distances between these. And how you do anomaly detection of this is after you have a trained set, after you have a model, if a new point comes in and either the Euclidean distance or the Hamming distance between the cluster points and this is large, above a certain threshold, let's say, then you would flag it as an anomaly. And a lot of companies actually use this for intrusion detection. So in areas of web security, IDS intrusion detection systems are actually using KNN anomaly detection techniques to detect if some hacker is going to your servers and doing weird stuff. That's not usually the case. Another one is support vector machines. It's a little complicated. I think the math of it is really complicated, but the idea behind it is not that complicated. You do the same thing in a vector space. You plot each audio sample as a point in vector space, and then you create a density function for this. And then if new points come in, you just run the density function against it. SVMs are used for dimensionality reduction and stuff. So in case you have a whole bunch of features and you're not sure which is the most important one, this can be used to reduce the dimensionality of your data point. You can use neural networks. I won't even go into this because I'm not very sure myself, but a lot of companies are doing this. Neural networks are just machine.
How prevalent are neural nets these days?
Yeah, I went for a neural net hackathon about a month ago. It's pretty interesting. I heard they were really hot in the 80s and 90s.
Yeah, that's what I worked on.
Yeah, cool. Yeah, I think they've been catching up in recent years. There's been a lot of work done. I think on Hacker News a couple of days ago, there's an article, Stanford has a class now, and I think they just released a paper, the graphics lab in Stanford released a paper that could use neural networks, and you feed it an image, and it'll be able to tell you what the image is comprised of in plain English. Right? So if there were a girl wearing a pink dress on a swing, you feed it through this thing, and it'll tell you girl wearing a pink dress on a swing, which is pretty darn impressive. There's no code for it, so you can't really test it yet. But if you take their word for it, it's pretty cool. I think I think neural networks do have a cool future, at least in like image recognition or things in which large data points, a large number of data points actually do affect the accuracy a lot, because neural networks require large data sets and require to have a pretty high threshold for inaccuracy. So I think neural networks are cool, and we should keep an eye out for them. Google, I think, is putting a lot of resources into that as well. It's deep learning or big mind group, I think. Also, then you have the ensemble techniques for machine learning, which always win the competitions. There was a Netflix, recommendation competition 3 years ago. I think like a lot of people have heard about it, where they offered $1 million to the team which could recommend users movies the most, such that the users would like them the most. And I think their accuracy at that time was like 0.35, which is pretty low. But considering the different kinds of movies that you could recommend someone, I think it's okay. Then they were offering $1 million to the team, which could bring this up above a certain accuracy. And it's always the teams that use ensemble techniques that win the prize, because you're basically mixing different techniques. You're mixing KNN, you're mixing clustering, you're mixing neural networks, and you take the best features that are generated from these, and then you just weight them somehow, and you increase your accuracy. So I think in production, a lot of people end up using ensemble techniques. So it's not a pure clustering technique, it's not a pure KNN, but ends up being really complicated. So implementation details of chain check. I'm done with the machine learning part. Our components are actually really simple. On the Edison board, we have two main crucial components that are connected to the board: a microphone and an LED. That's all. So we focus a lot on the software part of things, as you can tell. We just connected a microphone to it. We use socket I/O to communicate between the client and the server. So on the website, on our web UI, if you click a button, you can light up an LED. Just using Node.js socket I/O. And we use Node.js Super Agent to post data from the client, from the device to our servers. And we're actually using a very hacky approach to do this. So we record an audio clip on the board, and then we send it to the server. And we couldn't figure out how to send binary data over, so we're just encoding it in base 64 binary and then sending the string over. It's not actually that long, and it works pretty well. We're gonna figure out how to do that properly in the future. Yeah, problems we faced. I think this is what you were talking about earlier. Typical interface for audio sampling uses I2C. But the Edison system on chip doesn't really support it out of the box. You can add a driver for it by recompiling the kernel using Yocto and BitBake and stuff like that. Edison uses SPI for the analog digital conversion interface, which is more appropriate for discrete messages rather than streams of data. So that's why we had to implement our own stuff. In the end, we ended up using USB audio. Edison is basically a Linux computer, so we're taking this approach, just installing the USB audio drivers. And there's a pretty wide community online supporting Yocto and different takes of it. So it wasn't as hard as we thought. It was possible at least, but still not straightforward. The Edison board is not suitable for AV peripherals, so if you're looking to do an AV project, you have to have a UI or something like that. Go with the Raspberry Pi, I think. That's the most straightforward approach. We didn't know this initially, that's why we chose to do a project that was heavily reliant on audio, but it was still a good learning experience. Something that I thought was pretty peculiar about the board was Wi-Fi doesn't persist between restarts. Out of the box. It's not that straightforward to do that. I thought it was interesting because it seemed to be a big focus of the Edison board, like Wi-Fi functionality, but it just doesn't do that. So I hope they do that in future releases. Yeah, so this is the Edison board. We have two sensors connected to it, LED and sound. This is the board on a bicycle. This is what we used on demo day, and also what we use for test runs after demo day. Basically have a small bento box cloth-like sachet attached to the bicycle frame. And then we have the microphone connected and a light connected to the handlebar area. Then we have the microphone going straight to the chain and derailleur area so that we can capture more loudly the sound and capture more intricacies of the audio that was being generated. Yeah, Intel likes to film a lot. I wonder what they do with the footage. They film every single team, and they kept interrupting us like 3 or 4 times during the process to ask us questions and stuff. A really simple web UI implemented in Node and Angular. Just to display the sound clips. Just visually, you can actually see differences. This is when the chain was making an abnormally, muffly sound. You can see that the sound signature is slightly different. And according to a friend who is more expert at bikes than we are, you can tell what's wrong with a bike by just listening to the sound of it. Not sure if people listen to Car Talk on NPR, but they seem to be able to do that a lot. Just describing the sound, the squeaking sounds, and they're able to tell you what's wrong with the car. So hopefully this technique of anomaly detection can be used on more things than just bikes. Okay.
So can you go back to the picture of the audio signals?
Yeah.
It looks like there's a beginning part where it's low and then the second part where it's high.
Yeah.
What's causing that?
Okay, so the beginning part that is low and high, we tried to line up the audio signal such that between each click of the chain, there would be an audio sample. And because I guess in this sample, the chains were clicking pretty in a pretty synchronous and rhythmic fashion. So you see there's actually a line that kind of lines up from sample to sample, and that's actually a click of the chain.
So how much time is that whole picture then? That's not much time then, right?
Yeah, it's not a lot of time at all.
Okay.
Yeah, so it's not a lot of time at all, but it's actually pretty simple to just join them up and then listen to a longer sample clip.
Is there reason why you showed us more the time domain instead of the frequency domain?
No, there's no reason. It's because really this was like a last hour and a half hack before the presentation. So yeah, we haven't spent a lot of time working on the web UI since after the hackathon. We've been focusing mainly on getting USB audio to work properly and just getting the proper audio signals and also the machine learning techniques. We took the bike on test drives and tried to figure out. First of all, it's really hard to get a bike to brake when you want it to brake. So we wanted to gather signature sounds on when a chain was dry, and in order to do that, we had to kind of like artificially dry the gears, which was not that great for the bike and our heart. So yeah.
What is the time scale on those samples?
The time scales, it's not here. I believe it's milliseconds. So it'll be 15 milliseconds samples.
Okay.
Yeah. And yeah. Just an arbitrary choice we made. But it's really yeah. Sorry, this question?
Do the detection steps require speed or specific gear?
I'm sorry?
Do they require a specific speed or a specific gear to detect an anomaly?
Ideally not. A problem we were thinking about, a problem we haven't faced yet, but we think we will face in the future if we continue with this project, is everyone's bike makes a different sound. Initially, the idea of the project was to gather sounds from all the bikes that are using our product, and then we can tell when a certain bike is faulty. We can look for similar sound signatures in other bikes, but all bikes kind of make a different sound, so this doesn't really work out. If we're able to, distill out the differences between chains and somehow classify anomalies, then we think that it's okay. But there is no hard and fast, gear for this to work properly. We just have to tune it, basically. Yeah.
And he tried slapping this on a car.
There's going to be, just the same problem. I mean, a timing chain, not a timing belt, but a timing chain on an internal combustion engine, as it stretches, you have these same kind of problems. And timing chains are very expensive to replace, but they're even more expensive if they fail.
You have a huge sample set.
Absolutely.
I see. Yeah. We haven't tried that. Good point.
That's a good answer.
Yeah, we'll look into it. We definitely need to find more bike experts to validate our algorithms.
When it detects that the bike broke, does it call for help?
It doesn't call for help, but it tells you that the bike is about to break, so you can bring it to help.
Okay.
Hopefully. If this were to be used in a more mission critical use case, like in a car where the chain is about cars don't use chains. Like if something about the brake in a car, then I think we could possibly use like a call for help system. Yeah. So where to from here? I think I'm going to talk about edge computing next quickly. It's just something that I'm interested about. I think if we're able to rely less on the network, it'll be cool. If we're able to do more of the machine learning on the Edison board, it'll be cool. Currently, we're doing just sound signature generation on the boards, and we're doing very simple feature extraction on the boards, so we don't send a whole bunch of data over to the servers for nothing. It'll be cool to do a lot more machine learning on the board. So if you're out on the bike ride, let's say, it'll be able to tell you without any network connectivity if something's wrong with your bike. And Edison's able to do this because of the strong compute power. I think we're able to demonstrate a lot of the compute power by running complex machine learning algorithms on it. Also, we're going to work with real data and more user testing, which is pretty hard. So yeah, Intel told me I could talk about anything I like. I think I'm a bit over, but I'll just quickly talk about edge computing. Edge computing is kind of the opposite of cloud computing. Cloud computing is like a big buzzword that's been that's been talked about for the last decade or so. Edge computing is pushing the computing actions to the boundary of the network, such that less compute is done on central servers, and they're done instead on the logical extremes of each network. So allows analytics and knowledge generation to occur at the source of the data, so you're sending less things over the network, and it's more efficient. This requires leveraging on resources that may not be continuously connected to the internet, such as laptops, smartphones, and wearables, which are applicable to IoT projects. So there are two opposing models here. It's computation done on server and client. It's a very kind of dumb graph, but traditional data analytics do more compute on the server, and edge computing model is more compute on the client. So I took a class once, and this professor said something kind of interesting. He said that he realized that computing was moving towards two very polarized modes. One that's working on large centralized servers, and the other on small node objects that are like your mobile phone. So it's really moving towards a very centralized and then a very decentralized model. Cloud computing has exploded over the years. You don't want to hear any more about cloud computing, but the concept originally originated from a time whereby you couldn't do anything significant on a computer unless it was the size of your living room, let's say. So it makes a lot of sense to centralize computation on server farms. The world is big, network latency can't really get any smaller, there's a theoretical limit, but you can always cram more transistors onto a pinhead, so it seems like. This is the Google data center in the past. It's a Google data center today in Oklahoma. It's very interesting how much that has exploded. If that continues to scale, this was over 15 years. If that continues to scale, I'm not sure how much land space it requires. So look at how things have changed. Mobile networks have become more and more slow and unpredictable in comparison to the computing hardware that we have. Application latency requirements are falling rapidly, not because of anything tangible, just because this is kind of the age of instant gratification. How many times have you closed the tab on Chrome because the site took more than 3 seconds to load? I've done it multiple times. Big data analytics, it's becoming increasingly network bound just because of the amount of data that's being generated and being collected. And if it's being generated and collected, they have to use it somehow. So you're sending a lot of data to centralized servers to do machine learning on it. And as a result, network bandwidth is exploding. So it's really edge computing versus cloud computing here. So just a cool diagram I stole from NTT Japan showing the differences between cloud computing and edge computing. As you can see, there's let's say a more than 100 millisecond latency to send something to the server and then send it back when the compute is done. But let's say you distribute the computing throughout nodes in the network. You can actually lower the latency. If computation time on the server takes virtually 0 milliseconds, but the network takes about 200 milliseconds, if you're able to do the computation on your local device for 100 milliseconds, it's half the time. So why does it make sense to do computation on servers? Efficient bulk processing of data. There are some things that you can only do when you have aggregated all data points. Let's say map reduce. If you were to do a map reduce of all data that you collected from your users, you can do simple map functions on the local client. Yeah, but you can't do a global reduce without a shuffle. And in order to do a shuffle, it has to be done on the server unless you want devices to talk to each other, which ends up incurring a lot more computation. If you want to collect data on your users, which a lot of companies actually do and survive on, then having them send you less data doesn't really help your business. If you're forced to implement systems in a highly available fashion, as data centers are forced to do, it means that the system is quite fault tolerant, so you're able to give users high availability. But it ends up being very complicated. So Facebook has this Fabric server framework paper that they released, I think, a couple of weeks ago, and there's this cool graph on it. I didn't include it because yeah, it was just too complicated. But the lengths they go to make a server highly available is pretty interesting. So networks are expensive. As you can see, the larger a network grows, the cost of the network doesn't really scale linearly, it scales pretty exponentially. And at the rate networks are growing today, I don't think it will get any cheaper. So why client model? Networking speed is limited by distance and the speed of light, and it's not growing as fast as computation. So network latency is becoming an increasingly crippling bottleneck. And if computing a result of a function takes virtually no time on a server and is limited by network speed, then you should just do it on a local device. Yeah. So how is this related to IoT? I'm just interested in edge computing, and initially I thought there wasn't really much connection, but actually after thinking about it a little more, for a truly interconnected network of things, for a state of singularity, as they commonly say, I think all your household appliances, all your wearables have to kind of talk to each other. One of our teammates is working in a mesh computing startup, and he deals a lot with these problems. Distributing computing between different nodes in a server so that you don't overload a single centralized server. And communicating with the centralized server can be used for data aggregation, backup, or more intensive critical path computation. But if you can spread out computation between different nodes in a server, then I think it'll be much more efficient. So how realistic is any of this today? Storage is still an issue. The Edison only has 4 GB of flash. They can't really do big, machine learning on the Edison board because of data storage limitations. Hardware capability, it's competent enough. The Edison board is definitely competent to run simple machine learning classification, but it's not that fast. That's a big reason why we're not doing more complex machine learning algorithms on it today. It's bad business. You want to collect data on your users so you can serve them ads. At least that's what companies are doing today. But if you think about it, it's not actually that bad business. Think about what Apple is doing with the iPhone when you're encrypting data on their device. Companies actually don't want to deal with a lot of your private data. A lot of meaningful applications can only be done with data that's close to you. Let's say your heartbeat. Let's say the sound that you are making, your car is making. Do you really want to send that over to the centralized servers? If you can do all of that on the local machine, then companies don't have to deal with securing and ensuring that this data doesn't get compromised on their centralized servers. So I think it's a good trade-off that they make here. Edge computing is actually happening in the real world. There is a Center for Edge Computing that's run by the DOE and DoD. The US Army is using it on an Android platform for computing in the war zones. And I think there's a lot of interesting work being done in Imperial College London, whereby they actually have a whole range of implementations of edge computing in a network. Yeah, you can look it up. These slides will be online. I'll send them out. This is my last slide. So I found this article while making these slides yesterday. I think it's interesting because Intel is going to edge computing with Adeline technology, and that was a cool coincidence. I didn't plan this, so yeah, that's it.
Thank you, Clarence. We have 5 minutes for Q&A. If anyone wants to ask Clarence something, and then we'll move on to Antonio's Bluetooth smart lamp. Yeah.
Just a question, can you, on the Edison, cut the Wi-Fi off to save power and stuff?
Yeah, you can turn the Wi-Fi module off. Yeah.
And had you thought about sending data instead of from the Wi-Fi to some network, throughout the network, just to your smartphone, and use your smartphone as an edge compute device for your sound analysis instead of some network?
Yeah, I think that's definitely a valid point. We haven't worked with Bluetooth at all. It seems like Bluetooth will be a good way to send data.
Yeah, you can do Bluetooth as well.
Yeah.
It's just not as high a data.
Right, exactly. I think from what I've heard, other teams working with the Bluetooth functionality of the Edison board, it's not that easy. We tried to implement a Bluetooth thing during the hackathon, but failed to do so. I think a lot of teams also experienced that. So I think Bluetooth is less user-friendly.
Any other questions? Yes, Cruz.
How many projects would you say were completed, or I guess how many projects were worked on in your hackathon? Because I remember stopping by the one that was here in Austin, and it seemed like there were maybe a mishmash of projects. I didn't actually go attend it, but
yeah,
just wondering what the turnout was over in California.
Right. During the Mountain View hackathon, I think the presentations took around 3 hours. So there are about, I'd say, slightly less than 50 teams. So it was not a bad turnout because Intel was really generous. I mean, Intel usually is pretty generous at hackathons. They throw a bunch of stuff at you, free boards and stuff. So
speaking of, we have 3 giveaways we should probably get to. I almost forgot about.
Sure. Yeah.
Let's do that random number generator thing. So there's a, what do I got here? There's a Basis watch, an Intel Edison, and a C Studio Grove Starter Kit Plus. Which one do you want to start with?
Let's do the starter kit again. Okay, so Intel is giving away these things. This is a starter kit for the Edison board. And we're just going to do a random number generation, 1 to 111, based on the attendee list, the attendee list we got from the Meetup page.
So if you didn't RSVP, you're screwed. Thus, you should sign up.
Okay, 64. Wow. Okay, 64. I have a list of people here.
By the way, I told Clarence we needed a way to raffle this, and he coded this thing up in 5 minutes before the day. I was extremely impressed. I was like, yeah, there should be some kind of script to do this. And then he did it.
Jerome Hill here.
Jerome Hill. Where's Jerome Hill? Is he here?
No.
All right, moving on.
I actually know Jerome. I can bring it.
Well, no. Another surrogates. We're gonna check IDs too, just to make sure.
15. John Rodriguez.
John Rodriguez.
You know what? I'll forfeit that. Go ahead and move on to somebody else.
All right, that's right. He's unfair advantage.
Good.
Let's do it again. 83.
83 is Tim S.
Tim S. I saw his name earlier. I did not see him here. No,
just give him to me.
Mike DeGraff. All right. Yes. Winner. Chicken dinner. All right, let's move on to the next prize. Which one do you want to get away? The Edison board. The Edison.
What did I get?
You got the Seed Studio.
I have to actually have a board.
37.
37.
Christopher Mackey. Is there?
Yeah.
All right. Here you go, man. Happy day. Christmas came early. 95.
The grand prize 95. Josh Cross.
Josh Cross. Is there a Josh Cross? No. All right. Moving on. Who wants
66.
66 for the Basis watch? Jason Eccles. Hey, all right. Congrats. Wow, I almost broke it. There you go, man. Enjoy. All right, Clarence, well, thank you for coming and speaking and schooling us. Do you have something to show here? Or
Yeah, just
afterwards, if anyone wants to look at the board and stuff, he'll be around. But we have Antonio with his lamp, who launched a Kickstarter today. Can we keep that open and just bring up the Kickstarter page?
You know, a table, I guess I'll use this. Otherwise,
okay. Yeah, that's nice.
Thank you.
Yeah, just you should buy one. Are you still connected?
Okay.
Oh, right. So, can you see it from there?
Yeah.
Can you hear me?
We can now.
Okay, so what do I say now? Oh, by the way, take a picture of us. I wish when I was out of college, I would have been in an audience like this. So before you become famous and everything that take a picture.
Alright, cheers.
Yeah, I'll sell it in like 10 years. Or 5.
All right. Antonio's a regular at the meetup, so I'm happy to see his project. I spammed y'all earlier. If you didn't click the link in the Vax project, you should.
Yeah.
Do you want to play the video?
Okay. Oh. Yeah, you have to. So let me see. How do you start this? How do you?
Yeah, just click here.
Full screen.
I'm Andrea, and this is my dad, Antonio. I focus on the beauty, and his team focuses on the brains. Together, we have a dream of launching pretty smart homes, and we want to begin with our pretty smart plan. We have spent months together working to bring a product that not only appeals to the more design-conscious individual, but also to the inner techie. Quality is key for us. We're working with alabaster artisans and woodworkers that are local to our hometown. In doing so, we're able to closely monitor the production of our lamps and maintain a good relationship with our manufacturing partners. Alabaster makes for a modern, sleek design that can brighten up any room. Because we're using natural stone, each lamp is unique while still maintaining our high standard of quality. Our lamps are created using modern technology for precision, but are finished by hand to give you all the benefits of a handmade object. Simply tap on our lamp to turn it on or off, or use your smartphone to do so. We have added Bluetooth capabilities to give you total control of your lighting, and to give you features such as notifications in your preset color preferences. Because we believe in a future of smart objects, we've added a temperature sensor that allows you to monitor the temperature in a certain space and adjust it to your preferences with a smart thermostat. All of our features will be available in our user-friendly app, which will be available for both Android and iOS. We believe in a great user experience. We are working on simple commands for the many features our lamp provides. As new features are programmed, they will be available to you by simply updating your. So, it is with great joy that I ask you to come alongside us and begin the production of our lamp. Won't you join us?
All right. Can y'all see the lamp up here? The magical colors.
It worked. It actually worked.
I was doing a live demo. Awesome.
You know, it never works in demos.
Yeah, that's true.
Yeah, but I think this is the first demo in which it actually works. Well, anyway, well, thank you. I'll put on, that's a typical notification. So this was last minute. I wasn't prepared to speak or anything, so I think we'll just go directly to the questions. It's been quite a ride. We've been only a day and a half from Kickstarter. We launched yesterday. One of the things that is great, Bartley, I actually didn't come prepared, but I do have my list here. So you send the email after the email was sent. 3 backers came. So and it's been great. I mean, I want to thank not the Academy, but John Rodriguez, Dan Bryan, Robert Ristrop, David Endler, Scott from Eskil, Mutant Garage. Unfortunately, I did a lot of stalking, but I couldn't find the name behind Mutant Garage. Is someone here from? No? Okay. Bill Baker and Jamie Panagos. I hope, excuse my Spanish. I hope I did it right, but I mean, 7 backers from this group. If that's not support, I don't know what it is. We really appreciate your support. Yeah. So it's been going great so far. So since I didn't bring slides or anything, I'll go directly to the question and answer. So anyone?
Question in back.
Okay.
How much are you going to sell?
How much?
Okay, it goes from the regular one, which is 120. Then there's a special edition, which is 150. The reason of the difference being in that it's a rare white alabaster. So what makes the difference is that so this is a natural stone, and it comes in different colors according to the quarry, but the white is a purest form, so it has almost no stain. So that's the reason it. One of the reasons we wanted to go with alabaster and mahogany wood is because we wanted to go into doing something beautiful first, something that you would be thinking that you're buying, that will be part of your heirloom, that you'll pass it on generations. Ever since electronics came about, a lot of the furniture just dies in 5 years after the electronics wear off, or even sooner now. So one of the things we're thinking of doing, of course, you have the updates, but what when the actual electronics are outdated? So the alabaster, which is great stone for its translucity properties, yeah, something like that. You can keep that, send the base with the electronic, and we'll send the new electronics. And I think everything, all the furniture in the future, it should be like that. It shouldn't be something like what we have on the smartphone right now, that every 2-3 years you have to really throw it off and get a new one, at least in this group, etc.
Antonio, I have a question. What's you said they're made in Mexico, right?
Yeah.
You have a little logo there. So how do you have already personal connections to people that work with this material, or did you go out and find someone? Or
that's a very interesting question. I was actually researching for the different electronics materials, etc. We actually started. If we go down below, we actually started with. Here with somewhere there is we started with acrylic, which worked great, but at a certain point my daughter came and she gets it from the mom. She's the boss. Yeah. So she told me, why don't you make it out of something beautiful, out of that we would really like to have in a room, etc. So I started researching. There was a recommendation on alabaster. I started researching all the world through Alibaba. I got some Egyptian alabaster, which were the first one that started doing things with alabaster, but I didn't like it since it was yellowish and it changed the colors. Not yellowish as it's stained yellow, but yellowish, the whole thing. So I kept researching, and I found that just 2 hours from my hometown, Monterrey, Mexico, there were one of the best quarries in the world for white alabaster. So it was a great surprise. I went there, I met the guy, he's also from the owner, and started working with him. So it was a great experience. I went all the way to China to come back to my hometown.
That's all right, keep it local.
Yeah.
All right, we got about 2 more minutes left. One more question.
Yeah. I thought I saw earlier when I was looking at the Kickstarter page that you can set it to dim as you fall asleep. Is that based on a timer, or is that based on?
It's based on timer, and I mean I can keep going on and on about the different things that I can do. We're focusing on the beauty, but for example, I'm pretty sure you're familiar with beacon technology. one of the things it does, it constantly, it does have a beacon for two things. One, if you have your own application that for some reason is doing some beaconing, you can use it to localize your room. So it's great to know that you're in your room. So the way we're using it is like for notifications. Let's say you have your lamp, that is the one that you say, this is my lamp and it's on your bedroom, but you're in the living room. And you get a call. Of course, you don't want that notification appearing in your room. You want it on the living room. So the way it works is that the application detects that is on the that is on that's a notification. Thank you. He just called me. That's a missing call notification. So it follows you as the beacon does for notifications. For like for example, when you're in a certain room, you bring up the application, and let's say for any reason you have 10 lamps because you were a great backer. You have 10 lamps. But you don't have them all in one room, so you have distributed all around the house. So when you're at the room, you want to get the application, and of course shows the lamps that are in the room you're at, not the ones in some other room. So those are certain different things that you can do with it. It's a combination. Talking about what was it? Edge computing. It's the combination of everything that you can do here with everything that can be done in the lamp.
All right, that's all the time we have. For Antonio, thank you for demoing. We got one more demo after this. Thank you, Ryan. I see you in the back there. Ryan's a last minute addition. So, before I say that, back Antonio's project. We need to get him to his goal, and we've got 42 days.
Okay, thank you.
Awesome. So there, I sent you all a link earlier today. Check your spam folder or wherever it might be, and click it, share it with friends. It looks beautiful. So Ryan Craven, all right. Ryan's been here, I can't remember, like 6 months ago, 5 months ago. He's got this crazy hoverboard contraption thing, and if you follow the news, hoverboards are all the rage, apparently. So, Ryan, bring it up to the front, and we'll get you a mic. Okay, I don't know if there's enough room.
6 months really sounds like a short time compared to how it's felt. I've been working on this, juggling 3 $10 an hour jobs, living in a house with no heat. Pretty sure there's a squirrel in my wall. Basically, a lot of chaos surrounding this, and really, I don't have any mechanical expertise to have any logical reason to try to build a hoverboard, but for some reason, when I saw that hoax video in March, that's what I decided to do. And I brought in a version a while back and was focused on having a wheel that could access friction, but I realized I couldn't quite play with that element yet, so decided to go more for completely frictionless and found a way to balance this. It's loud as hell, but
turn it on.
Here we go. Video doesn't make sense to me, because if we're going to post video, it better go to the front page of Reddit and not just on your Facebook page. If you think that's something collectively this room could pull off, by all means, press record. If not, I'm just going to do it. I can do some 720s. As a skateboarder, I can't do anything more than 180. This thing really, in the way like an anti-gravity chamber would be fun. I started thinking about as being able to push off the walls is a lot more fun. And sorry, Mike, right? So this is an iteration. As I said, I'm working for $10 an hour right now. I turn 27 tomorrow, and I'm fairly confident if I don't make something happen, that's kind of the trajectory my life will continue on. And,
so in other words, you're asking for help?
I'm asking for help because I can't kickstart this unless I have proprietary centrifugal fans. I can't kickstart something that uses a Black & Decker product, unfortunately. I don't think they'd be unhappy about it, but I don't want to launch something and have it get taken down after we can find out the hard way. I really...
Get them to host you.
That'd be nice, but I have no idea how to make that happen. I've been... I've had people that have said they can help me with it, and things just happen and it hasn't, and I'm really looking for someone here that has a knowledge of centrifugal fans to help me bring this thing to life. The best part about this is, really after you watch that magnetic hoverboard video, there's a lot you can do on it, but there's a lot you can achieve on this as well, and it's not $10,000. It cost me $200 to make. So, cool. Anybody, please? I'll get on my knees.
So basically, Ryan's looking for an aerospace engineer, ninja, mechanical engineer.
Centrifugal fan is what I need, connected to a lithium-ion battery. That's
probably one out of the almost 100 people in here that either does that or knows someone, so...
Well, I mean, it's something I've had the opportunity through friends that say, bring it to Michigan, bring it to California, and we'll work on it here, but it really feels like a Texas thing. Like it happened a bit serendipitously by living in Texas and going to the skate park and thinking, how do I make something that's actually fun to ride? And yeah.
Well, I'll give you a real suggestion. I got a guy hooked up at Bolt.io, and they actually funded him, and Bolt.io came here.
Bolt, he has a connection at Bolt. I know Ben Einstein as well, actually, if you want me to, I can send an email.
Bolt.io came and talked here a while ago, like a year ago, and I referred one of my friends to them, and they actually funded something, which was nowhere near as cool as this. I think you could give them a call. The only problem is they are on the East Coast, and you do have to go there, and you do have to live there, and they set you up and all that, but they will put electrical engineers, mechanical engineers, IDs, everything to build a product. And that might be something to do because there's a lot of us in here that know mechanical engineers, but they're going to want money probably because they won't be able to work for free. But Bolt.io, that's a real possibility, so.
On that note, I'll say I've been living here all year and I love this place. It's great. If I miss out on a much more active social life back in Chicago, there's nothing tying me to the state other than I thought there were things tying me to this community specifically, and I really just wanted to get it done. While I was here, it made sense to keep chasing it, but if I'm not working on the hoverboard here, I'll work on it anywhere. If anyone else has a similar suggestion, but yes, please, let's talk more.
All right, request for help. That is a big part of why this community exists, so definitely.
I mean, it'd be very cool in my eyes to see Austin be the home of the hoverboard. I think even if it moves to the East Coast, you can't erase that it was conceived here, but yeah.
Get the video proof.
Yeah.
Awesome.
So that's my spiel. Thanks.
All right.
Thanks for listening, and I'll just I'll hang out in the hallway actually, so I can show it off a little bit more.
We have one question in the back, I guess.
No, and I desperately want to, but having only one, I'm terrified that I'm going to sink it while doing it. Not by the fact that I really think if I just sent it across without myself, it wouldn't be any problem. It's negotiating entering the water that would be the interesting part that only gets more interesting as it gets colder.
Try to build a hovercraft and try to take it on water. That does not end well.
I mean, I figure either way it'll be a really fun moment to cut away and figure out maybe 2 weeks later in the dull moments of a Kickstarter what will happen. But put it this way, if I can't get this one to do it, I certainly believe I can get a later iteration to do it. The original design's based off of it's supposed to be able to handle water. We'll find out.
All right. Well, we got a little bit more time, so we'll break, and whoever wants to help out Ryan with his hoverboard, surely someone here can do that. Antonio can talk about his smart lamp, and he'll try to sell you 10 of them. And Clarence is over here he knows everything about machine learning, things and whatnot. So I'm Bartley Gillen. Thanks for coming out. There's a little bit more pizza left. Eat it. Take your beer. Take it home with you. Road beers are good. Throw away the trash if you can.